Scope of course. Besides the GPS positioning accuracy efforts that are well documented in the literature and discussed above, this course embraces the present-day work documenting the performance evaluation of GNSS systems and new receiver designs to improve GNSS signal quality before the processing. The up-to-date experiment results on positioning accuracy are also evaluated for online GNSS software, which is freely available to user community. In addition, the positioning accuracy under severe atmospheric disturbances is evaluated for single-frequency receivers, which are widespread in surveying practice today. The structure of the sections and lectures is as in the following. In the first section, the performance of the two GNSS systems, GPS and BeiDou, is evaluated. Referring to well-established standards developed for the GPS, the performance assessment of BeiDou satellite navigation system is performed. The available signal in space, SIS, model is improved based on the reliability theory using exponential distribution and Gauss-Markov process, and constellation models are refined taking into consideration satellite failure rate, repair rate, and backup situation. The second section reviews the quality of the GNSS measurements. In the first lecture, a new GNSS receiver design in which the GNSS signal is repaired using a new vector tracking architecture is proposed. In the second lecture, how the GNSS signal is degraded under severe atmospheric disturbances such as ionospheric scintillations is investigated. A calibration model improving single-frequency PPP results is presented. The third section is devoted to GNSS positioning assessments. Chapter 1 and Section 3 assesses GPS relative positioning accuracy for a single-frequency GPS receiver. Single-frequency receivers are economic and suitable for nationwide surveying practices. Therefore, researchers are eager to develop methodologies in which single-frequency receivers are employed. Here the positioning accuracy is assessed taking into consideration the mode of surveying, baseline, and precision dilution of position, PDOP, signal-to-noise ratio, SNR, and occupation time. Chapters 2 and 3 in this section assess results from online GNSS software. Results from available software are compared. Chapter 2 presents results in ITRF-14 and Chapter 3 in the National Grid System. The fourth section is devoted to the construction of national spatial reference systems by combining terrestrial geodetic networks with GNSS networks. A recurrent adjustment methodology which uses GPS data from GNSS methods is presented applying sparse matrix operations, outlier detection, and simplified subsystem of observation equations. Namely, present-day accuracy of establishing national spatial reference systems based on GNSS is presented.